Hi, welcome to this first video on how to read and report and understand the stats and results reported in primary research, primary scientific research. Remember, these videos are not about how to calculate the statistics, but just how to understand them as they are reported in scientific research articles, in primary research articles. And remember, it's all about breaking down the wall between the science establishment and the layperson. In this case, pulling down the wall. This is a picture of a wall coming down on New York Avenue in Washington, D.C. In this video, we're going to go over these 5 things: mean, mode, median, normal distribution, and standard deviation. If you've already taken a stats course, this is probably a review for you, so you don't even need to watch the video. I am going to show how it applies to reading specific tables and stuff in primary research, but this may be stuff you already know. So here are the first 3 terms, and you've probably heard them before. The mean is another word for average, and it means, say you're given these 5 numbers here, you add them all up and divide by the number of numbers there are, in this case 5. So the average for this set of numbers is 10. The mode is the number that appears the most often. In this case, 11 appears 3 times, so it is the mode. And the median is the middle number when you line up the numbers from smaller to bigger. So 1, 2, 3, 4, 5. This 11 is the median. So what does this look like in real life in a primary research article? Well, you remember the penguin study, which we looked at earlier. This was a study where they induced emotions in the participants by showing them a film, either a penguin's film, a nature film, a film about sticks, a film about bullying from Witness, and a film about rock climbing called Cliffhanger. 2 or 3 minute clips, and they tried to elicit emotions, and they wanted to, then they asked the participants on a 0 to 8 scale, how high did you feel, at the highest point that you felt this emotion during the 2 or 3 minute clip, how high would you rate it? So they rated the clip on the 9 different emotions. They only watched 1 clip. They rated it on 9 different emotions. And this is the results that they got. So here are their results, the table 1 from that article. And you can see there's 9 emotions here and the 5 different films across the top. Let's look more closely at the top of this table right here. So we can see that the penguin's film got a high rating for amusement. 7 is the mode, the answer that was listed most frequently. So there were 104 participants, maybe 30 of them watched the Penguin movie, maybe 2 or 3 rated the amusement level 0 or 1 or 2, maybe 4 or 5 rated the amusement level as 3 or 4 or 5, and maybe 10 even rated the amusement level as 7, and maybe 5 rated the amusement level as 8. So it's the most frequent number. It's not the majority, just the most frequent number that's listed as an answer. And the mean, of course, is different. The mean adds up all the different answers, some of those 1s and 2s, like those 1s and 2s and the 3s and 4s, however many there were, adds them all up, divides by the total number of participants who saw the Penguin movie. Of course, that will be less usually than the mode, in this case because the mode was so high. It also makes sense that the Penguin's film elicited most commonly a 0 in the anger, but somebody at least said something because there's a mean that's higher than 0. So somewhere in that average, a few people felt a little bit of anger, and that brought the average up above the mode. Same thing with anxiety and contentment. Even contentment, the mode, the most commonly reported number on the Likert scale, was a 0, but a bunch of people did feel contentment, which makes sense, and that brought the average up, the mean up to 3.62. And then you can see here that the nature film really didn't elicit too much amusement, but a little bit, because the mode is 0. That means on the emotion response test, when they were asked about the nature video, those people that watched it, on a scale of 0 to 8, how would you rate your level of amusement watching this video? And the most common response was 0. But some people marked higher because the mean was 2.57. Same, in fact, even the Sticks film elicited a little bit of amusement. Even the bullying film elicited a little bit of amusement, and even the cliffhanger film elicited a little bit of amusement. Whereas, look at this one. This is very interesting. The bullying film from Witness, the anger, the most common result was that people listed that as an anger level of 8, the highest they could for that film. But some people obviously listed less because the average turned out to be 6. And in fact, mode is not something you often see in primary research. You always see the mean. The mode is not as commonly a reported statistic, but this was an interesting one to read about. So where does the median come in? Remember, the median is the number right in the middle of the whole list of data points. And you often see that reported in a box and whisker plot style. So if this was a whole range of values, the median is the middle value. If you count to the 25th percent value, so say there were 100 values, value number 25 would be right here at Q1, and value number 75 would be right here at Q3. This is called the lower quartile, and this is called the upper quartile. So between here and here, between Q1 and Q3, if there's 100 values, are 50 data points, the 50 middle data points. And then out here, the whiskers, this is the highest data point, and this is the lowest data point. And this obviously is called the interquartile range. Now, a box and whisker plot sometimes looks a little bit different, and I'm going to show you that next. Here's the other kind of box and whisker plot. Instead of bringing the whiskers all the way out to the maximum and minimum value, they stop the whiskers at 1.5 times the interquartile range. In other words, right here is the median, here's the first quartile, here's the third quartile, and you could see that the difference between Q3 and Q1 is about 10. So 10 times 1.5 is 15. So they'll bring the whisker out to 15 beyond the 75th percent or the Q3, and 15 before the Q1, and that's where they'll end their whiskers. They do that because sometimes the very far outlying values are just not helpful to the research. They're too far. They're going to mess up the statistics. They just want to get most of the data. So maybe this was a research into how old people were that went to a certain movie, and for some reason they weren't interested in the outliers, the 30-year-olds and the 80-year-olds. They just were really interested in the distribution of the main majority of people, and it seems that the main majority of people that went to this movie were between 50 and 60, but a good chunk of them, probably 95%, were between 38 and 73. So that's a good thing for maybe the advertising researchers to know. So that's the other kind of box and whisker plot. It just leaves off the very far outliers outside of the whiskers. And here is a typical set of data from primary research using the box and whisker plots. Remember that the middle line is the median, and this was the results of the study where the researchers took 23 children who ate conventional food, and every once in a while during the year they replaced all their conventional food with organic food, and they tested their urine on all different days to see what the level of pesticides were in the children's urine. So the organic diet days are labeled here, and these are just the days throughout the year. So you can see that for this pesticide, TCPY, the average level of TCPY in a child's urine was about 5 or 6. And then it dropped down on the first day, day number 5 through 9, were the days where they gave the children organic food. You can see it dropped down to 2, and then even down to 1, and even down to 0 by the 4th day of organic food, and it stayed down at 0 for the next 2 days. So you can see that just looking at the medians, the level of pesticide dropped drastically just by switching out of conventional food into organic food. And you can see here they use the plus and minus 1.5 quartile type of box and whisker. All these circles are outliers, and these dots are what they labeled actually extreme values. So they left out the outliers and extreme values, and you can just watch the median go down, and it came back up again when they stopped eating the organic food. Then they redid it again in the fall. The organic diet days are 95 to 99, and you can see that in the fall, the average level of pesticides in urine is lower anyway, but it still dropped when they switched to the organic food. So that's interesting. Let's look at another one. This is a different pesticide called MDA, and the results are even more dramatic. They were spread out more. Look at this scale, isn't even a regular scale, it's a log scale. So they might have chosen to use a log scale for this pesticide because the outliers were so far away from the median. Look, this outlier is at 100 micrograms per liter, whereas the median is at about 1 or 2 micrograms per liter. And but then again, you can still see that the median drops down to basically 0 as soon as they start eating organic food, both in the summer and in the fall. Okay, that was mode, mean, and median. Now let's move on to normal distribution and standard deviation. You have seen this curve before, and the reason I bring it up because all the statistics calculations, which we are not going to do, are really based on a normal curve. So we need to understand what a normal curve is. Let's say, for example, that we had, 200 or 300 students in a school, and they're all selling candy bars. And how many candy bars do they sell? Well, about 5 people sell 100, about 15 people sell 110, 20 students sold 120. Right here, this is 150. So it looks like 45 students were able to sell 150 candy bars. And way at the top, there's these 5 stars up here that sold 200 candy bars each. But as you can see, the distribution of sales by the different students fell on a normal curve, what they call a bell curve. And you've heard of these before. Sometimes people grade on them, and the bell curve, the middle will be a C. You go up 1 standard deviation, you'll get to a B, that type of thing. So a bell curve doesn't happen with every test. It doesn't happen with every population and everything you're testing, but it happens a lot, and so that's why they use it for statistics. There's this really great website where you can create your own bell curve, so I'm going to show you that really quick. This is at the mathisfun.com website. It's called Quincunx, and we're going to speed it up a little bit. We're going to keep everything else the same, restart it, and we're just going to run these marbles through the nails, and you can see that the bell curve just basically forms. Where do they land? It's a little bit to the left now, but if we wait long enough, we'll get a bell curve. It will look just like, ooh, it's not doing it. Look at that. That's interesting. We'll go to 100, and we'll go to, so this one is very interesting. This didn't happen. I'm going to stop and we'll try it again. It was skewing to the left because there's no center spot. So I'm going to change it to just 5 levels of nails. Here we go with 5 sets of nails. And I'll stop it at 100. So there you see that the bell curve happens a lot with a lot of populations and a lot of different experiments. And you can come back and play with this on your own. Remember, it is mathisfun.com. You can change the size of the nails and everything. So here's what the famous bell curve looks like from a statistician's point of view. And right here would be the median. They set it at 0, but it could be whatever the median and the mode and the mean will always be in a real normal bell curve. It'll always be that middle spot. It'll be the most common score that you get, and it'll be the average score that you get, and it will be the middle score that you get as well. So it will be right there. And then you know about the standard deviation. If you go up 1 standard deviation to the right and 1 standard deviation to the left, you will capture about 68% of your results. And if you go up 2 standard deviations to the right and 2 standard deviations to the left, you will capture a total of about 95% of all your results will fall in there. And that's important, as you will see later. But for right now, it's just good to remember that once you do the calculation, it's a statistics calculation, figure out what the standard deviation is. If you go up 2 to the top and two above the median and 2 below the median, almost all your results will happen in there. 95% of the results will happen in there. So depending on the type of experiment, you might have a large standard deviation or you might have a small standard deviation. If you have a large standard deviation, that tells you that your data is really spread out. You're not getting the same results for every person. You're getting a very wide range of results. Whereas if you have a small standard deviation, every person, every subject, or every whatever you're doing, the results are coming out pretty close to each other. And here's a picture from Khan Academy showing what that might look like. The standard deviation for this set of results, all these data points, is 1.59. And you can see they're kind of clustered around 5. Most of them are in 4, 5, and 6 as a result of whatever type of test they did. Whereas in this one, the standard deviation is 2.79, and the results are really spread out. There's some at 8, there's some at 3, there's some at 4, 5, and 6 as well, but there's some way out at 10. There's even one down at 0. This is a standard deviation, which again is a statistics calculation that you can do, but we're not going to do it. But everybody that does stats knows it and does it. That shows me a standard deviation of 2.79 when the median is 5.2. Shows me, wow, stuff is really spread out. If I go 2 standard deviations down, I'll get to 0. If I go 2 standard deviations up, I'll get past 10. So it's telling me, wow, 95% of my results in this blue experiment are going to be between 0 and 10. But this one, 95% of my results are going to be from 5 minus 3. So 2 standard deviations is about 3. So 5 minus 3 is 2. So from 2 to 5 plus 3 is 8. And you can see that actually almost all the results are between 2 and 8 in this green experiment. So what does standard deviation look like in real life in these primary research examples that we're reading about? Well, back to the Penguin and other films, they do have the standard deviation on this table as well, and typically it's in parentheses listed after the mean, sometimes next to each other, sometimes underneath. So if we look again at the penguins, we found that the mean is 5.33, but the standard deviation is 2.36. So 65% or 68% will fall between about 5.33 minus 2.36, so about 3 and 7.6. That is where 68% will fall. But if I go down 2 standard deviations down and 2 standard deviations up, that's about going 5 down and 5 up. The 95% gave a result between 0 and 10. Well, big surprise, because it could only go from 0 to 8 anyway, right? But that tells me that there was a fairly wide range of scores. Even for the Penguin film scored on amusement, there was a fairly wide range of scores of amusement, all the way down to from 0 all the way up to 8. Let's find one with a smaller standard deviation. Here, for example, the standard deviation is 1.41, and this was anxiety. So the nature film obviously didn't induce a lot of anxiety in people. If you go down 2 standard deviations, you go down below 0. But if you go up 2 standard deviations, that's about 3, so that'll take you to 3.67 or 4. So 95% of the respondents in this one marked anxiety as 4 or down for the nature film, which makes sense. Now normally, standard deviation is reported just as you saw in parentheses. But every once in a while, standard deviation is actually a result that's interesting in and of itself. So these are the results of a study about sleep quality and academic performance in college students. And they had students wear trackers. They had 100 students wear trackers for a bunch of days, and they figured out how many hours of sleep they got, and they compared it to how many, to what their grades, their average GPA was. And so each one of these circles represents one of those students. you can see that this student here, despite getting only about 5.5 hours of sleep per night, was pulling an 80. This student up here that was pulling a 93 actually got 9 hours of sleep. There's a couple people down here with very low grades, and they were getting 6 to 7 hours of sleep. But then up here, a bunch of people were getting 80s, or give or take a little bit, and they were getting about 7 hours of sleep. You can tell by just the density of the blue. And so although you can't see a normal curve in here, you can see that the peak is right about there, and the grades are they're spread way down from 30%, and then they kind of come up here, and then they kind of go down, and it's a little bit skewed. There's a little bit more, definitely a little, it's probably like this. There's definitely a little bit more here around the 80s and a little bit around the 90s, and then it really has this long tail over here by the 30s, the Fs basically. And also the amount of sleep they got. You can also kind of see a normal curve here. The average amount of sleep looks like it's right around 70, and it kind of really normally curves just around there. Something like that. But here's what I meant when I said they actually use the standard deviation as a result in itself. They calculated the standard deviation of hours of sleep. So if over the days of the experiment, say the 30 days of the experiment, you have a wide standard deviation in your own personal sleep patterns, sometimes sleeping 3, 4, 5 hours a night, sometimes sleeping 9, sometimes sleeping 7, that will give you a wide standard deviation, which would be up here. If you are consistent about the number of hours you sleep every night, it's always 7 or 8, that will give you a low standard deviation down here. And as you can see, the people that were more consistent with a lower standard deviation, 1.51, they are getting better grades. So that's an important aspect too. Be consistent with your sleep and you may get better grades. Remember, this study doesn't show a causal relationship, just a correlation between consistent sleep patterns, low standard deviation, and the amount of sleep you get, and good grades. A correlation, not a causation. But it's good to know and to suggest further study. So that brings us to the end of this video. If you were unfamiliar or needed a review, we went over the fact that mean is the average, mode is the most common number in a list of numbers or data points, median will be the middle number, and you can see that very often on a box plot. The normal distribution or bell curve is what they use to calculate so many statistical entities or variables, and the standard deviation is amount you measure off of this normal curve. If you're at the median and you go up 2 standard deviations and you go down 2 standard deviations, you will contain 95% of the data points within that breadth of 4 standard deviations. Thanks for listening.